All right. Let's make sure we get the correct angle. Throw that guy over there. Hey, how's it going, man? I'm still setting up, so give me a moment. This is gonna be informative, I'm sure. Can you guys hear me? Everything's going all right? Hope the audio is clear because now I'm trying the audio on this guy. I forgot my lapel mic, so I don't have my lapel mic, unfortunately. So I hope this is coming across nice and clear. Okay, excellent. Thanks, guys. Give me just a moment. I'm going to post that I'm doing the stream. Hold on. Today, I've had slightly less caffeine than the last time. It's a good thing. That means I'm not going to be running in front of the camera, and it can keep track. So, come on, camera. Where are you at? There we go. Okay. All right. Today, I'll be a little bit slower, and hopefully today the camera can keep up. There we go. All right. Let's see. See, normally I have time to set more of the stuff up, but unfortunately I got caught up with something and I was unable to. Here. Sometimes it's faster to use your phone. Okay, let's see. What's up, man? How you doing?
How are you?
I'm doing good, man.
You ready?
Yeah, absolutely. We're gonna cover soldering. I got some materials in my office. I got to go bring them out here. They're watching. You want to see? You want to see? People talking smack right off camera. Let's see. What was I doing? Okay. Today we're going to cover the intro to soldering. I would like to get into maybe some other stuff, like maybe some surface mount. But for the most part, today I want to make sure that everybody has a good grasp on soldering in general, because there's a lot of wrong information out there. And I do quite a bit of board repairs and cable repairs and stuff. So I've got a pretty good grasp of what I'm doing. I'm not the authority on it, but I got a pretty good grasp. All right. There we go. Okay. We're a few minutes early still. So doesn't it seem like when you've been drinking coffee that everything runs slower than what you'd like? Like, I kid you not. I just posted something, and this is the gobbledygook that I posted in my phone. Post. Oh my goodness. Hold on, guys. Let me put you guys back up so I can see what y'all are typing. All right. Oh my gosh. Let's try this again. Okay. We're up. We're good. This one here. See, whenever I do social media, there's like several places I got to post to. So it takes like a whole extra half hour to 40 minutes of my time because I got to post to all these different sites and whatnot. It's kind of a pain. But that's the most effective way to get the news out, right? Let's see. First. Okay. All right, I think that's set up. Now I can go get the supplies from my office, and I'll be right back. So, guys, I'm going to have some links in the video description of some of the stuff that we're going to be using today. So if you're interested, you can check it out on your own. I've got some really good soldering kits. I think they're really good anyway. We're going to put that to a test. And I got some practice boards and stuff because one of the things I've always supported whenever I have teammates and junior biomeds is I always get them the DIY soldering kits and I set them free. And I show them the correct technique and how to inspect their joints and whatnot. And then I give them some of these practice boards, and I want to see how well they do. It tells me a lot about who they are, you know, their attention to detail, their perfectionism. There's a lot you can learn about somebody as a technician just based on how they can solder a board. If you show them the correct technique and how you want every single joint to look like, and they do that, well, then their attention to detail is pretty good. So let's see. I'll be right back, and I will go and get all the stuff we need to get this thing started. Okay, camera, stop. Camera. Okay, camera. Me and you, we got a problem. I see the blue light. Okay, there we go. Okay. All right. Let's see. Come on, camera. There we go. It's tracking. It's tracking. Okay. Let's see. So for today, these down here, pop this over here. So we're going to be going over wire-to-wire connections. We're going to be going over through hole, maybe some surface mount. We're going to be going over consumables, the different tech that I use when I'm doing board work and whatnot. We're going to go over that. I'm going to show you guys. I got a whole bunch of stuff set up here. We're going to go over the consumables, which is probably one of the most important things that we can go over because there's so many different consumables, and knowing to use the right one, the right application, it's going to save you a lot of hassle. Oh, let's see. Somebody says, what state and city are you in? You want to know my home address? I'm in Houston, Texas. And it is still a balmy 70 or so degrees outside. It's beautiful. I know some of y'all are covered with snow, but sucks to be you. All right. Let's see. Got about another 2 minutes, and then I can call the guys over and we can get this party started. So I'll give you guys a sneak peek at what I'm going to be handing out. Every time I do one of these videos, it costs me hundreds of my own dollars out of my own pocket. And because I believe in this so firmly. So last time I got the guys some things. This time I got the guys some things. And here we go. So these are the soldering kits that I got for everybody. And there's a lot of stuff in these. Plus, I've got, this would be a digital clock. It requires an external power source, but it's still a digital clock. And what we could do is we could have the guys put it together, not necessarily today, but it gives you a lot of practice on one little board. And then we can bring it over and hook it up. And if it catches fire, they did something wrong, right? So that's going to be part of the thing. We're also going to do some realistic applications. things like this, when you have a pre-wired, what is that, pigtail that's connected to something like a battery, we'll be going over all that. These ones are easy. Just got to make sure you got a powerful enough soldering iron. You get a bunch of stuff. Let's see. I just got to wait for the guys. And hopefully people won't be yawning this time. Hollywood, Florida. All right, man. Hopefully I'll be visiting Florida again sometime soon. Good times. Holy cow. So hopefully today is not going to take an hour and a half. All right. So today's going to be all right, man. You've got probably, yeah. The camera's rolling. Don't make me say something that's going to get me in trouble on the camera. I probably should have eye protection, right? Hold on. Let me go get my eye protection. All right, man.
Estamos en vivo. Camera follows you.
That's right. All right. To be proper, right? Somebody's definitely going to get on me if I'm not wearing these. You guys ever wonder why nobody trusts you? All right. It'll be all right. No, this isn't going to be edited. This is straight. Like, if we mess this up, then well, we just have to come back to work tomorrow. Just watch your mouths. This time here, I don't have my mic, so now they can hear everything everybody says. Like normally, they only hear me, and half the stupid stuff that comes out of you guys' faces, they don't hear. I'm just playing, guys. All right. So, guys, we're going to go over all these components that I have over here, what they do. We're going to go over the consumables because there are a variety of consumables that we use. We're going to go over technique. We're going to do wire-to-wire technique. We're going to be doing maybe some terminal soldering, which is where a lot of people kind of mess up because terminals are usually in plastic. And if your technique's really bad and you just bury your iron in there, you're going to melt the plastic and you're going to booger it up. So, guys, I have a kit. Hand it to each one of you. You don't have to pull everything out of it at the moment, all right? Because that would be a disaster. And I got one for Jeffrey too. So, in there is pretty much everything that you need to do to get started, okay? And then some, all right? So don't burn anybody's houses down. Because unlike these ones, those ones don't have any safety protections in them. Like you plug it in, you come back 2 days later, it's still on, okay? So don't be messing that up. Okay, and you guys might as well take one of these each. So these are a digital clock that you're going to build yourself, okay? And then we're going to inspect it. we'll see how good you are, all right? So these here, that'll be basically like the test because there's a lot of stuff that you could possibly do wrong on those. Like there's certain components that can only be inserted in one direction. So some of your capacitors are electrolytic. They have to go in a certain direction. Your diodes have to be in a certain direction. I don't know if there's any diodes on there. I haven't opened it up. I don't know. But pay attention to detail, okay? I'm going to show you guys the correct technique for how the components should look when they go through the board. And I'll show you guys when we do wire to wire and stuff like that. We'll do that in just a moment. So here, I'm going to turn the camera so you guys can see what's going on over here. All right. All right, me and the camera, we're getting along better today. All right, on this bench this is probably a little bit over the top, okay? But I have my regular soldering iron, which I might as well go ahead and turn on right now. I've got a hot air station, which is this guy right here. This is a regulated DC power supply. We can use that for power and test things and whatnot. Not really part of the soldering thing, but it fits, so it stays there. And this guy here is a solder sucking gun. So if you have components you have to remove from a board, you stick it on there, you melt it, you hit the button, and it sucks all the solder out. Makes it so much easier, trust me. Because we're gonna work on the technique using solder wick, and then there's the type that use your solder sucker, and then there's that guy. You're gonna find out why people prefer that. So the first thing that we should talk about is that soldering is not welding. Okay, so welding takes your two base metals and it melts them together. Okay, soldering takes two clean base metals and it adds another component between them to make them stick together. I don't want to say stick because people are going to chew me up in there, but that's pretty much what it is, right? So it creates a bond between the two metals, and it does that with an alloy. The alloy is usually, for traditional stuff, it's usually lead and tin, okay? Now, these ones here, I want you guys to take notice that they're normally called a 60-40 mix, which is your percentages of tin to lead. Now, I know some people are going to be watching this in other countries where they don't want you to use leaded solder or whatever. Guys, we'll cover some of that too, but it's okay, all right? We're in America, and many other countries, we can still get leaded solder. Whatever people tell you about leaded solder, I've known people that have worked in electronics for 40, 50 years, and they still have their teeth, okay? So it's not like lead is killing them that quickly. All right, so this here is a 60-40 tin to lead. So 60, tin, 40% lead. It's very pliable, it's malleable, and it's ductile. So it's a very soft material, and you can flatten it out. You can draw it into really thin, tiny wires. You can see that solder comes in different gauges, okay? So you can get some really thick stuff, which you can use for like copper if you're brazing pipes or something, or if you have a lot of stuff to do on, let's say, a ground plane, which is the edge of the board or something, you're going to switch to this because you're going to go through half the spool if you use the thick or the thin gauge. So here you guys, two different ones. So not all are going to be 60-40. Some of them are going to be like this one right here. It's SN63 PB37. So 63% tin and 37% lead. The reason I'm telling you guys this is because you want to use the correct solder for what you're doing. So you can mix them usually. Some people are going to flip out about that on here. I don't care, guys. Just calm down, okay? Hold on. The thing is if I have a circuit board, which, hold on, let me get a circuit board. Yeah, I got some over here. My first victim. No, I'm not going to mess up this board yet. All right. Okay, so if you have a circuit board like this, these are going to be pretty much all put on there with solder. Okay, unless we got some circuit boards and some medical equipment that's really old, that's going to be your leaded solder. But these ones here, any modern day medical device, is going to be solder. And generally, you want to use some lead-free solder when you're working on them. The difference between the solders is that leaded solder melts at a lower temperature. It's so much easier to work with. Lead-free solder, it melts at a higher temperature. It's kind of gummy, kind of sticky. Your iron has to be at a hotter temperature, which means you have less time to be on the circuit board before it messes it up and burns it. So generally, what I will do if I want to remove a component from one of these, is I will add leaded solder to the joint, which let's say I'm pulling out these pins down here. I would add some leaded solder to the back of these, and then I would go ahead and suck it all out with a solder sucker, and then I'd pull it apart, and then you clean the joint. We'll go over all that, but it's okay to mix it because I'm going to clean the joint anyway before I put the new component in. And then I can put the new component in with the lead-free solder. It's okay. Some of these guys will trip out and they'll be like, oh, no, never mix your solder. Yada, yada. Yeah, I'm telling you, I'm going to hear about it. I already know. I've done it many times. So the reason that I'll mix the solder is you also want to create a bigger pool of hot metal because that conducts heat. Just a soldering iron tip, like this guy right here, it won't conduct heat so well. So what I have to do is I have to put a little bit of solder on the tip. Now I touch it to the joint, and now it conducts the heat better. I can sit there for 10 minutes holding this down, and it won't melt. It won't melt. It won't melt. And then I just put boop, a little tiny dab on there, and so that's where a lot of people get it wrong, and a couple other things, but we'll go into that. Okay, so soldering station. This one here is it's hot as shit, isn't it? Probably shouldn't have turned it on. That's okay. So there's different types of soldering irons. Some of them have changeable tips that have the heating element in the tip. Okay. Other ones, like the ones that you guys have, those ones are going to have changeable tips, but the tip sits over the heating element. Okay. That's the most common soldering iron that you can find. This one, in fact, is that way. Here, let me pull this guy out. So this soldering right here, it's battery powered. I love this guy. So I can pull the collar off, and you can see right here is the tip, and it sits over the heating element. So I have to be very gentle because it's a ceramic heating element. You can bust it, and then you're stuck. So here's the tip. It fits over, and my collar. Now you're probably thinking, why would you want to change your tip? Well, the tip basically changes the properties of the iron. Okay. If you have a fine point like this one right here, that's fine for some detail work, but it's not going to conduct very much heat. So if I have, let's say, a terminal on a battery or something, I can get it to work by putting it sideways, but if I try just the point, it's not going to work very well. So when I'm doing some larger components, like these guys down here, which we'll get to later, I have to lay the iron across the terminal to get the most surface area to conduct, and at the same time add solder to it, as I said, because liquid solder conducts heat better than the tip itself. All right, so that's my soldering iron. This is adjustable. I hardly ever touch the temperature, okay, guys? I almost never do. This guy here is a hot air station. The hot air station is a cool asset to have. I can do shrink tube with it, which is pretty neat. I can melt solder on a large component. You see this large guy right here, this port? Ports and pins are some of the most common things to get damaged. But there's a lot of pins on the back. You see all those? Now, how would you get all those liquid at the same time? Doing it with an iron would be impossible. It would take forever. So what we do is I would take this guy here. You can see when I is it really flickering on the camera? It's making the lights flicker. But then you run this back and forth. You preheat the board. Once the board starts getting warm, then you can go through and start melting them down. And then the whole port will fall right out. Just got to be careful, okay? Because that will heat up the whole board, and you burn your hand. So this is a hot air station. A lot of places that don't have a hot air station, I encourage them to get it because it makes some things so much easier. If you're changing out like a large port or a chip or something like that, it makes it way better. Plus, I use this all the time for just doing heat shrink tube, which we'll get to in a minute. So heat shrink tube, I use a lot of it. I use a special type. We'll go over that. So that is my base soldering station and hot air. I keep a portable soldering iron. This one's very similar to the ones that you guys have. This one's always in my toolkit. It's got changeable tips, even though I almost never change it. All right, I just work with what I got on it. And this guy is very versatile. So those ones are all very versatile too. That's what I had in my toolkit for absolute years. It's going to be wonderful. So this guy over here, this is the solder sucker. And this guy has a heated nozzle and a hollow tip. And what happens is when it gets up to temperature, oh, it's got to get up to temperature before it does anything. It's actually heating kind of quickly. I'm already at 400 degrees Fahrenheit. So you can see when it's sitting in the dock, it won't be at temperature, and then you pick it up and it senses that, and it knows, but it's got a little reservoir right here where it stores the solder. When it sucks it, it'll you can see some of it splash right there, and that has to be cleaned every once in a while. So if you do very much of this, it has to be cleaned. You just pull this down, this comes out, you dump it out. So pretty easy stuff, man. So let's see, is it almost a temp? Come on. I don't think I've ever been so impatient. Okay, there we go. 720. All right. So when I do this, so it's hot, and what I would do is you stick it over a pin, and then you liquefy the pin, and while it's liquid, you do that, and it sucks all the solder out. It's so much easier. But that is not the way that most people do it. The way most people do it is they use this guy right here. So this is, you got one of these in your kit. This is the universal way. You have to have like 3 hands. You know, it's very cumbersome. So you're melting the solder. Meanwhile, you stick this down there while it's hot, and you hit the button. It sucks it up, and then you dump it out. But that is a solder sucker. This guy over here is for fumes. So, you know, that stuff you don't want. Obviously, it's probably not the healthiest thing in the world, right? So we do not want all those fumes coming up into our lungs. Yes, we have eye protection, right? But now you need lung protection. And this guy, when you're soldering, should be on. And it sucks the fumes and it blows it right towards you guys. No, I'm just kidding. It actually has a activated charcoal here, and it grabs a lot of those particles and it absorbs them. And this you have to change out. Soldering irons have to stay clean. That's probably one of the main things you're going to learn is if the tip, this one is a wee bit dirty, they oxidize when they get hot, which means the metal will develop a layer on it. Solder does not want to stick to that. So when you get an iron, you turn it on. Let's go ahead and turn this guy on. Even this guy. This guy. Yep, this guy's oxidized as well. So for all you guys that are looking, an oxidized tip is dull. It's not shiny, and it usually has some material mass, maybe even some flakes on it. So the first thing you do when you get a soldering iron, no matter what, that's one of the reasons I keep this large solder floating around, because it's so easy to just touch the soldering tip. Okay, so let's not do that over your board. Okay, so what I do is I just touch it to it. See how it gets all shiny? So inside this right here is something called rosin, and rosin is basically a flux. And flux is a material that cleans the metal. So like I said, when you have 2 base metals and you try to get them to stick together or bond together, they have to be clean. And the only way to clean it is with an acid. So we have this type of flux, which is a paste flux. This one's an acid. And you can see, or let's go ahead and turn this guy on. I have a feeling that that's going to be bad for the microphone. Okay, well, see that? So that, look how clean that tip is, though. See that? Looks fantastic. So there's 2 ways of cleaning your soldering iron. One of them is a wet sponge, like you can see here. The other way is with this mesh material. Now, the reason people prefer the mesh material is because it doesn't change the temperature of the iron. Usually when you have a wet sponge and you dab it on there, it kills the temperature of the iron, so it has to get back up the temperature. So if you're doing a lot of work, you're going to be cleaning your tip quite often, you know, because it's going to oxidize while it's just sitting there. Like it's already changing color. You can see it. See, it's purplish. Watch this. Isn't that crazy? So you want to keep the tip clean because solder does not like to stick to a dirty surface. So that's why there's a solid core, or geez, I'm thinking about something else at the moment. There's solid core and then there's rosin core. We only use rosin core because it's got the flux built into the wire. You can see all this brown stuff right here. This is flux. Okay, so it's inside the wire. You can see how the wire is hollow, and that is what cleans the tip of the iron. It's got a layer of acid that basically cleans the surface of the metal, and then I'm wiping it off in this cup. So if your soldering iron tip is not shiny, it's not ready. Okay, so this one's ready, but watch, it's going to oxidize within seconds. See, it's already purple. So we clean it, shiny, it'll turn purple again. All right, I'm just going to leave it there. So we have flux, and then we have flux. Okay, flux is an acid. So when you use it on a circuit board, you always have to clean it off. Okay, don't leave it on there. It will. You can see what has happened to some of this. See that? That's only from yesterday. Okay, it changed it to brown. It's already corroded the copper, and this will turn green. It's already started to turn green right there. So you guys, just so you can see, shiny copper. This is flux applied to the copper. It's already turning green, and that's over 1 day. So it is an acid. It does eat away at metals. So we clean it off, and we do that with alcohol, rubbing alcohol. Okay. And now this is electronics alcohol. Is different than some of the stuff we have here in the shop. This is 99% pure. So what that means is that if I spill this on something, unlike the other one, it will completely evaporate. The other one, it still has water that's part of the component. This, you can put it on something. Here, watch this. It will completely evaporate quickly, and it doesn't sit underneath microchips or anything. So 99% pure alcohol is what we use to clean circuit boards because it won't corrode, it won't damage. Anyway, so we have flux. We use flux often. Now, I gave you guys circuit boards that have components. You don't need flux for those, not necessarily. Some people argue that out, they could shell off. All right, well, you don't need flux because on those boards there, you have a clean metal, and generally the components are clean too. So when you have flux wire and you're just doing those do-it-yourself kits, it'll just stick. It'll just work. So you don't need to worry about flux for those. If you're doing rework on a board that already has stuff, yes, you need flux, okay? Because what flux does is it makes the solder stick to the area that you want it to. Without flux, I could put solder on like the legs of this chip right here, and it will bridge between the legs. Like it'll bridge them together, and that's a short. That's really bad. But with flux, if I put flux on there and then touch it with my iron, the solder will just liquefy to the nearest metal, which is the leg, and it separates. It's the craziest thing. So flux is like the key to making a joint look really beautiful. Without flux, solder gets really gummy. Like you can touch it with the iron and kind of drag and make lines with it and stuff. With flux, you can't drag and make lines. It's not going to happen. It wants to stick to the iron or stick to the joint. And you guys will see that in just a moment. So here, let me go shut that guy off. After we have the flux and the solder, next solder wick. Now, this is something that you'll find all over the place. There's different grades of solder wick. There's different thicknesses. Like this one here is really thin. Some of them are thicker. So you can see there's different gauge. The reason that we have different gauges is because copper absorbs heat, right? So if you use too big of one, it's going to suck up too much heat for what. So if you got a little component that you're doing or something, it's best to find like a smaller solder wick. The thicker one, if you got a big old joint that you're trying to pull a whole heap of solder off, I use solder wick very often. And one of the things I'm going to show you guys is that a lot of people use solder wick wrong. All right, a lot of people, and they get frustrated, they get all pissed off about it, It's just a clear case of you're doing it wrong. The key is flux. Because like I said, flux makes metals want to stick to each other, right? Without the flux, it'll just go all over the place, which is what happens when people usually try to use solder wick. So I'll show you guys an example of that. So that's our solder wick. We use that for sucking solder a joint and cleaning the joint, and then the component will just fall right out. If you do it correctly, it will just fall right out. So that means you use plenty of flux, and sometimes if there's not enough solder on the joint to get you going, you might have to add solder. So that's, some of these boards are really skimpy. Some of these components, there's almost no solder on there. So you have to add solder to your iron and then touch the joint. Yes, a little solder will go from your iron to the joint, but then now you can suck it off, because you have to have solder in order to remove solder, if that makes any sense. Because otherwise, you know, some of these, that's a clean board. Take a look at those traces. There's almost no solder on there. That would be really hard, even with that solder sucker, to get them off. That'd be really hard. So the key is to add just a tiny little bit of solder, which is why we have this little thin stuff. So all you gotta do is just touch, 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 and just add a little, and now you can remove it. All right, so that's enough talking about that stuff. Let's go ahead and get into the practical side of it. So I'm gonna show you guys a technique for joining wires, one wire to the next. I'm gonna use this wonderful tool right here. They're magnetic. You're gonna absolutely love this guy. Make your life very easy. I'm from the old school crowd. I'll use like a set of pliers or something and stick your wire through the plier so it's just sticking up. This is kind of a luxury I never really had. So let me go through these. Now I'm going to show you guys the correct way to solder wires together, and then I'm going to see you guys do it. All right. So at the very end of this, you guys are going to plug your irons in, and each one of you, I'm going to have you guys try and solder wires together the correct way, and we'll see how you do, because I think you'll do rather well. Once you see somebody do it correct the first time, you're good. The rest of the time, it's going to be way easier. I had nobody to really show me the correct way to do this. Okay, so I'm going to remove maybe a third of an inch at best, quarter of an inch maybe. So not very much. And let's say this one right here is going to be my victim. I'm going to remove about the same amount from this side. Okay, there we go. So here is where this becomes key. This. If you're joining two wires, they're going to be exposed. You don't want them exposed. So if you're joining two wires, always remember your heat shrink tube, all right? So I use a special heat shrink tube. This stuff here is called dual layer heat shrink tube, or sometimes they call it marine grade heat shrink tube. That means that there's glue on the inside. So it's really thick, it's very durable. It's not flimsy like the heat shrink tube that's inside the kits. This stuff here is shiny on the inside of each tube, and that's because when we melt it, it's going to melt glue in and around the joint, makes it waterproof. So if you're going to be in a surgical environment or something, you're going to find out this is going to save your bacon. So I'm going to cut off just the right amount of shrink tube for my application. So if what I do is I stick two wires together like this, and what I want is a little bit of overhang for that. So right about there is going to be plenty. Let's go ahead and use some shears. Guys, my chat is way over here. I'm sorry, guys. Yeah, you guys that are watching, trust me, this is the soldering iron to get if you're going to be working in the field. No, I can't adjust the temperature. That's fine. I don't need to adjust my temperature. You find out your technique matters more than the temperature on the iron. If you got a good technique, you can be fast. You're not going to damage the board. You'll be fine. Okay, so let's see. I'm going to set one of my wires up here and here. And then this guy. Hold on, guys. You're in for a ride. Okay. Can you guys see that? No. little guy gets warm. Yeah, yeah. Can you please? There you go. Over there, they can see exactly what I'm doing, and not being such a weirdo. Okay. All right. No, you don't need to focus.
No.
It does it on itself.
See, recording.
So the number one thing I told you guys, the soldering iron has to be clean, right? You can see it's dull. It looks like garbage. So I'm going to clean it, and then I'm going to touch a little bit of solder to it, right? This is called tinning the tip by adding some to it, all right? I'm going to clean it back off, and, screw it. I'm going to use this at 60/40. Okay, so what you want to do is you want to prep your wires. Some people will try and join them without prepping the wires. I always prep my wires first, which means you tin the little piece of wire that's sticking out. So just like this. So what I'm doing is I'm not sticking the solder to the wire. You can see my iron is touching the wire. I'm actually on the wire and I'm adding solder to the hot wire. So you want to heat up the part, not the solder. Okay. If you heat up the solder, all you're doing is melting solder. The way that the solder bonds to the metal is that the metal gets to the temperature needed. Okay. So you can see I'll put it on there. It gets all shiny. I'll add just a little touch of that. Now, one of the things I want to show you guys is when I tin my wires. See if I can show it. Okay. When I tin my wires, I leave kind of a bulb of solder on the tip. And that is what I'm going to use to bond the two wires together. So here we go on this one. I'm going to touch the iron to it. You can see I've got a little tiny bulb of solder on the iron. Here, let's go ahead and clean that guy off. So it's nice and shiny. Let's stick some solder to it. Stick that on the wire. Now the wire's hot. Now look, see how I can move the solder up and down the wire? And see that bulb of solder right there. That's very important. And the way that I get that bulb is I'll put a little more on there. See how I pull the iron away slowly? Now the solder wants to follow the iron. Okay, so if I move this up, you'll see the bulb move up. See that? So the solder always wants to follow the heat. So what I do to add extra solder to the wire is I slowly pull the iron away. See how it leaves that bulb? So I have a bulb there. I have a bulb there. Those are prepped wires and they're ready to go. And just lay that down. Okay. So now what we're going to do, I'm going to, let's see, I got my heat shrink on before I join the wires. That's the most important thing. And now I'm going to put the wires just like this. And I'm going to lay them right next to each other, just like that. And as I put the iron on there, they're going to melt and bond together. See that? Can you see how I move my iron side to side? Now you can see I have too much solder on there because I was given a bulb example. But for that, I can just remove some solder with the iron. See how it sticks to the tip? As long as the tip is clean, the solder will want to stay with the heat. Okay, now I removed all that extra solder. Let's go ahead and redo these. All right. Let's remove some more. Okay, so this here is what they call a cold solder joint. You see how it just moved? You can see that little tiny crack down the middle. So a cold solder joint is when it didn't bond completely. And that's what normally happens when you add solder real quick and then pull away. You melted the solder, but you didn't heat up the metal. It'll create a cold solder joint. Now, cold solder joints are one of the biggest problems for circuit boards and stuff because that's usually what it is, especially around connectors and whatnot. So what you want to do, if there's ever any doubt, is to do it over again. There we go. Come on. So you can see I've developed this technique of using my hand. Wait. Hold on. Okay. So this wire here, you see how it's dirty? I'm going to add more solder to it, clean it. Because if it's not clean, see, that's a clean joint. Now this one's dirty, clean. See that? Once you get two clean ones, now you can bond them together. Look at that. Okay. So you see, I didn't get it right the first time, probably because I'm talking and working with my hands here. But I did the second time. So once you get your joint good, now normally I would check it with a multimeter for continuity. I've made that mistake of heat shrinking the heat shrink, and then you have to open it back up later because you found out that it wasn't done right. I've made that mistake several times. Okay, so you can see the heat shrink is just long enough to go past each. Maybe I'll go past it just to make sure. And then we get this guy. Okay, so we don't use electrical tape. Electrical tape is horrible. We use shrink tube whenever possible. Whenever we make a joint, we're gonna use shrink tube. Okay, and I told you that this is dual layer. So what you're gonna see is near the ends, it's gonna shoot out some glue. So it's gonna be shiny near the edges. And this is the only type of shrink tube I use on medical equipment. There you go. You can see I got glue shooting out here and over here. It's shiny. That is a watertight bond, and we're ready to go. Okay, now I'm going to show you guys one at full speed. All right. So that is one joint, but let's say on a typical cable you have more than one conductor. Okay. So with more than one conductor, let's go ahead and mess it up. Should I do it the wrong way or the right way? Okay. So you can see I cut them at different lengths, right? The reason I cut them at different lengths is because if you make all your joints at the exact same point, you'll have a big old fat bulbous right in the middle. Okay. So your heat shrink tube will like skinny and they'll be really fat where all your joints are and then skinny again. So the way that you fix that is you cut them at different lengths and then you strip them back and you do exactly what I just showed. So let's go ahead and do that real quick. Okay, so that one's set. Set. And the reason I'm showing you guys multiple wires is because now we have a whole extra step that we're gonna have to do, right? So after I strip my cables, what's the first thing we do? Yeah, it's definitely dirty. You're right there. Okay. We have to tin the tips.
Yep.
So you twist the wires if they're not already twisted, and then we're gonna tin each of the wires. Okay. That one, not good enough. Okay, that's almost the perfect amount. Okay, there's one. Let's see. A little twist. There we go. There's two. A little bit too much solder on there. There we go. Okay, just a little bulb on the end. We're good. Okay, clean that. Now we get this guy. Tin it. Come on. Okay, that one's good. Okay, and that one looks good. All right, so the extra step is now we have 2 layers of shrink tube. All right. So let's say this guy here, I'm gonna cut it down to here. This one's gonna go on first. Okay. This is gonna cover up each individual wire. So if we're doing a cable or something that's got multiple wires on the inside, first we do is we put the outermost shrink tube on, and then we'll put on the smaller ones that are going to go over each wire, and then we do them all together. Okay. So let's get the 2 skinny ones. We got this guy. Let's see. There. I'm going to put those on this side. Right, that way there we keep it a little clean. And this one here, about the same. All right. Let's do this. Okay, black wire, and you're gonna see it's much easier to be ambidextrous when you're soldering because sometimes you're gonna have to solder with your left hand, sometimes with your right hand. Come on. Oh, it's moving. There we go. There's one. Normally, I'll shrink tube that one as soon as I get it done because you don't want solder sticking to solder, which can happen. There's two. Okay. That's it. Stick it back. All right. So once I got those two, put our smaller shrink tube on. Hit. Hot air station. Here, let's go ahead and turn it up. Do it from both sides. So remember, it's dual layer, so I want to see that glue squirt out each side, which there you can see it on the red wire starting to come out. Okay, there's that one. And now we put the outermost shrink tube over it. So if this was normally a cable, that would be the end of the cable or the break in the cable. So you can see I'm getting it from both sides. Okay. And we put this guy back. You can see when I put it away, it goes into a dormant phase. This one here will also go into sleep mode. When you pick it up, it wakes up. But anyway, if this was a cable that had an outer sheathing, that would be the repair. It would be corrected that way, right? So remember to put your outermost one on first, and then you put your smaller one on the smaller wires, and then you go forward. Okay, guys. So what I would like to do now is set you guys up at each of the tables, and we can break out those irons. Let's make sure that they work. And I will get you guys some wires so we can test out there we go, right? Okay. Here, one of you guys can work from this station if you want. Okay. Just remember, guys, if you make a mess at a soldering station, always clean it up. There's nothing worse than like sitting down at a soldering station, you get like little specks of wire in your arm from the last guy that was up there. So always clean your stripped wire pieces and everything. Tell you what, I seen that you did a video on solder suckers. It's interesting for all you guys out there watching. You can test your solder sucker by hitting the button, and you can see if the plunger gets the suction. It won't go all the way to the end. This one here is obviously loose. It's not the best, but there is some suction, and this guy does work pretty good. Oh, a Weller WR3M. Okay. And a Pace MBT 350. I think I have a Pace. I think I have that. And Mr. Hasib, you are absolutely right. It must flow into the wire in order to tin. So the wire will become very rigid, and that's how you get the two wires to make a really good bond. Do I recommend sold ECG wires or solid ECG wires? Would I recommend soldering ECG wires? Absolutely not. I mean, you can do it if you're in a pinch. You can do it. If you're in the United States, I would not be doing that. So the thing is if you have a patient that let's say has an artifact or not an artifact, let's say they have an arrhythmia and it didn't pick it up for whatever reason, they can always blame the Biomed that did some alterations on the ECG cables. So if your ECG cables are ever defective in any way possible, get rid of them. That's in America because lawyers, you know. So do not fix ECG wires. That's bad juju. Okay, because you know when family members, when loved ones die, they always try to find somebody to blame. Don't be the guy, even if it had nothing to do with why he died. Don't be the guy. Okay. All right. Let's see. You guys can. One of you guys can sit here. Let me get some wires for you guys, and that way there, you guys can work on some other things. So I didn't show components yet. I know that everybody's anxious to get into the components, but let's do some wire. Yes, let's do some wire because once you perfect wires, now you can deal with PCB because if you hold the heat on the PCB, which is the printed circuit board, if you hold the heat on there too long, it'll damage it. And there's actually a practice board in there. You see that? Yeah, that little board right there. So we have some resistors right here. These are extras. We can practice soldering to that before you do that one. So that'll help you get used to your soldering iron. Tell you what, let's choose 68K ohm. Why not, right? But we're going to practice with some wires first. Okay. Okay. Here you guys go. Here's yours. We're going to cut it in half. Okay. And I want to see you guys join the wires together. All right. Okay. This is shielded cable. There you go.
Oh, but I can take this.
I'll get you some wire strippers.
Let's
see. Where are these ones? So the reason I'm giving you guys this wire is because this is a 2-conductor wire. It's very common to what we're going to use in foot controls, hand controls, things like that. Are going to use this type of wire. Let's see, who doesn't have wire? Fernando, you got wire? Here. Here. There you go. Yeah. So there's two conductors in, and then there's a shielding conductor. So no, you just can use the black and the red wires. Just the black and the red. The shielding conductor, normally you just have those kind of touch. Don't worry about that. I don't even care about shielding cables right now. That's another level. You guys got wires over there? Oh, you got those tiny. Here, let me hook you guys up with a longer wire. There you go. You're gonna match that one with that one. Okay. Let me know if you guys need some more wire. What brand wireless soldering iron do you recommend? You know, okay, so that's a good question. It depends on what set of tools you already have, because I see that Ryobi has a portable soldering station, which is very cool. I don't have any Ryobi tools, so other words, I would use that. But this one here, this is a Milwaukee brand, and this uses the M12 batteries. So that's the reason I use the Milwaukee, and it's really well designed. So if you need to work at an angle, you don't want all that weight up top, you could actually use this for production work if you needed to, because it heats up really well. Um, I'll give a demo on this later, because even though it seems like it's bulky, this I've actually used in the field several times. One of the reasons I had to use this is on surgical tables. Sometimes the IEC power input plate has welded wire or soldered wires to the terminals, and you either buy the OEM part or you just get another IEC input, which is, you know, that little six-sided thing that the cord plugs into, and you solder your wires back to that and heat shrink it. Pretty simple. Really simple stuff, guys. Okay. You want to use this? Go ahead. Go ahead. Now I used to use just pliers to hold the wire up so that I can tin it and stuff. That's an option. But I have helping hands, which are these things that are clingy. Look at this. Ha! That's crazy. I didn't even think about that. Here. And I got some long ones for you guys that are used to using, you know, other tools. What are you laughing about? You're welcome. I've got vices too, because sometimes you have to use a vise to hold your board. So I've got several different vices. Now I was going to get you guys some power cord, because that's easier to see because it's bigger wires. But we should never really be soldering the power cord. It's just a bad practice. So other than like the IEC input plate, I would never solder power terminals or anything. Oh yeah, that's right. It is ESD safe. Here's something for you guys. I have only once throughout my entire career, and I've fixed things for well over 20 years, I've only once ever seen a popped chip due to static electricity. Once. And the reason that it popped is because I was working on a motherboard to a photocopier, and they spilt toner all over the inside of the photocopier, and I was vacuuming it out. Well, toner is tiny, minuscule pieces of plastic that are just kind of shredded up. And the toner gets melted into the paper, and that's what we call ink, right? Toner is plastic. Plastic, if you ever rubbed a sheet of plastic, it creates static. Well, I was vacuuming the inside of this photocopier because it had a lot of toner that was spilled inside here. And then I went over and I started vacuuming the motherboard, and I heard a pop. I audibly heard a pop, and it wouldn't boot up. It was done. So that's the only time throughout my whole career I've ever heard of anything about ESD actually killing a device. It used to be back in the day that ESD would affect all sorts of EEPROMs and you name it, especially memory modules and whatnot. But ESD, for the most part, if you're working on a whole PCB, it's not that big of a problem. Let's see. People are rating. Sorry, guys. I'm going to try and stay on top of the comments this time. You know, one of the most annoying things about Windows is it always tells you need to update. That's the updates take priority over everything else, so I can't see what the comments when it says I need to update. Hasib says they must solder by holding the wire in the fingers, and when the fingers heat, they'll feel the warmth. You know, my fingertips don't feel heat very well because of that very thing. You know, that's also how I know that the insulation is about to give. Like I'm giving it too much heat to the joint. It's because I'm holding the wire while I'm soldering it in, and if my fingers can't hold it anymore because it's too hot, you need to ease up on the heat because that is going to melt your insulation on the outside of the wire, which is going to, you know, destroy your wire. Am I going into troubleshooting to PCB? You know something? I could do a whole video on that, troubleshooting on a PCB. Maybe while they're doing that, I can find a PCB and I can show you guys how to remove components. I've got some cool stuff I'm going to do a video tomorrow on, right over here. Some vintage technology that was given to me today so that I can do a video on it. Very cool. I love old stuff, man. All right, how you guys doing? So your soldering iron, I would set it to, it's in C, right?
Yes.
I would set that bad boy at about 350 to 380 on your iron.
Yeah.
You break something already?
Yeah.
Would you admit to it if you did? I would set it to 350 to 380. Did you adjust the temperature on your iron? Oh, okay.
Right? That's the one you want to do?
Yeah. Yeah. So the reason I said that it matters more about technique than the temperature is because as your technique gets better, you're not going to heat up the joint as much and you're not going to kill the board. So that's one of the reasons that people try to keep the temperature as low as possible. If you're really good with the iron and you got a good iron, you can apply the heat to the joint, melt your solder, and then pull it away. It's you're not going to kill the chip or whatever that you're heating up too much. What you looking for? Oh, yeah, yeah. That's probably a good thing. I should probably get everybody some solder, huh? Here, I'll tell you what. This is the best solder right here. This one. Try that one. All right. And I will go ahead and get you guys each a strand of this. This is some old school stuff. I think this is for like 20 or 30 years old. It's going to be fantastic. Probably is the best stuff we got in this building. Yep. So this little sponge right here is a sponge that you normally wet, which here.
Are we using the sponge?
Yeah, you can use the sponge.
I got one.
Okay. All right, thanks. I just don't normally use the sponge because it cools the tip down a little bit too much. To be damp, not sopping wet, just a little damp. Okay. Yeah, and it'll expand. So how's it going?
We're adding right here.
Yep. So remember to touch the iron to the wire,
You want
and
one?
then when the wire
the
starts
sponge?
getting hot enough, that's when you'll feed some
I'm
of the
okay.
solder. Okay. Yep. A little on the iron. Touch it to the little wire about halfway down. Yep. Now put some. See how that's gummy, and
Yeah.
it's kind of that's because there is not enough in the flux. So what you're gonna do is you're gonna feed some wire into it, some of that. Yep. And you'll watch it'll change its properties as you melt new wire. New solder. Yep. Clean the tip. Really good. You can even just shake it and it'll just pull right out.
So I did.
Yep. Put a little dot on there. Okay. Now touch it to that, and you're gonna feed the wire, feed the solder into the iron. Okay. Hold the soldering iron in one spot. Now feed that into it. There you go. Yep. And you're gonna see it's gonna clean the wire as you feed the solder into the joint. It's going to clean the wire, and you're gonna see some scale, which is that dark stuff. It's just gonna roll right off. Yep. Your soldering iron tip is pretty dirty. If anything, you guys can use that guy too. That's my favorite way to clean the tip. Right. So you're gonna hold the iron in one spot and feed the solder into it, because when you move the iron around on the wire, you're breaking contact, which is gonna cool the wire off, and it's gonna create a cold joint. That's why it's not sticking. All right. Mr. Hasib Electronics, thank you very much for joining. And go get some sleep, man. I understand it's the middle of the night for you. All right. So hold the iron in one spot, feed some into it, and then once you got a glob on there, then you move the iron down the wire, and you'll find the solder will follow it.
Is this too much or is it like about enough?
Let's see. Well, see how it's got this little bulb down here at the bottom?
Mhm.
Little bulbs like that are going to damage your heat shrink. Okay, so let's see how much you got in there. Okay, so what I do is I put them right next to each other, just like that, parallel.
So not at one point, kind of like
Yeah.
cross.
So once I see it melt one wire, and then it'll melt the other wire almost instantly. Then you see me move the iron down it, and that spreads it because the solder follows the heat.
All right. That's
Yep. Let's move you guys more central.
Then we're gonna solder this together.
You want an extra wire?
No, me, I got it. So we're gonna solder into this.
Yep.
Using heat shrink.
No, not necessary. I want you guys to get your technique of matching and bonding your wires.
Oh, okay.
That's the most important thing. That's actually pretty neat. With the power supply up top, the power strip, the wire isn't dangling across the desk. And that's, knocking stuff off your desk. Carl Stout, thank you, man, for tuning in. Thank you very much. Remember, these recordings will be online so that you guys can access these at any time. And if anything, I'm going to bring in a microscope so I can show you guys right up close what it should look like. I was going to bring one today, but I couldn't figure out how to tie the video feed in. So I need to be able to tie it in so that you guys can see it. Holy cow. Have we already been going longer than an hour? No way. All right. Okay. So you see this little sharp point that's popping up right there?
Yeah.
Touch it with your soldering iron real quick. And you want to, any points, sharp points like that, yeah, you want to get rid of those because when you put heat shrink down, it'll poke through.
Oh.
And it will short out. So guys, if you ever have solder mass and you got a little icicle poking off of it, smoothing it out with the iron, even if you just touch it real quick. Because if it pokes through the heat shrink, it will damage the wires next to it when they're all bound together. So never leave the little pointy mass on your bonded wires, okay? What you got? What you got? This one's excellent. The black one's excellent. This one here is actually pretty good. I mean, that little guy right there sticking out. So I'll tell you what, this does happen, so what you do is you take this guy right here. Yeah, it's all about not letting it poke through the heat shrink tube. So that's good. Those are good. Now, you can see the outside it's melting a little bit. Don't worry about that. Just make sure your heat shrink is long enough to cover all that. Yep. Excellent. Your wire is dangling. You got to support it with your hand. There you go. Yep. Those look pretty good. There you go. Those are good thin wires. Those will bond nicely when you put the other one right next to it. So those look pretty good. So all you do is you're just going to put them right next to each other like this, and stick your iron on it. And when they start melting together, just rub your iron like that, and it will stretch the solder between the two wires, and it'll be nice and uniform. You guys want me to give away another shirt? I think I have some shirts to give away. I can definitely do that. Juan asks, will you be showing solder wick technique? Absolutely. So that is the next phase. So first, we're going to teach joining the wires, and then we're going to teach through hole, and then solder wicking, which is going to be the last piece, because that's usually the most difficult. So there is an order. We're getting there. I had no idea that we were over an hour. No idea. And I do have a very nice giveaway that's coming up very soon, guys. So you'll have to stay tuned for that. Better than a t-shirt, I promise. So when you have globs like that hanging out, these tools over there, this is called a flush cutter. So guys, this is called a flush cutter. And if you have any wires that are kind of hanging up a little bit, you're going to shave them off nice and flush so that your wires are as parallel as possible. Remember, we don't want anything poking through the heat shrink and arcing on something else or maybe damaging another wire. Get a little bit of solder on your tip. There you go. Now you can feed it in. Hold the soldering iron in one spot. There you go. There you go. Perfect. Perfect. Yeah, when you're heating it up, don't move the soldering iron around so much. That's all right. We will get better at this. This is PVC, the insulation. That's plastic. It melts at a lower temperature. I will get you guys better wires to do this with. But these wires right here are very common to what we find in foot controls for microscopes and hand controls for tables, ritter tables, whatever. So that's why it's good to practice with this wire. So one of the next things that we're going to do, once you guys have bonded some wires together. Looks good. Looks pretty good, man. So yeah, the only other thing is obviously you strip this back a little bit further and put small shrink tubes on each wire. But that's okay. We don't need to shrink tube anything. Okay. That might be coming at a later thing. Next, we're going to practice with the through hole, which are obviously you get these resistors right here. There's a little practice board. You see it? That came in the kit. So you got some resistors as well? Mm-hmm. Excellent. So go ahead and put those resistors through a couple of the holes. You're going to have to bend the legs of the resistor over and poke them through the holes. And then once it goes through, you're going to spread the legs of the resistor to hold it in. Okay.
Doesn't matter how far apart.
Nope, doesn't on this board. Doesn't matter at all on this board. Could be 2 apart from each other. Could be 5 apart from each other. It doesn't matter. So when you put these guys through, put them all the way down. Okay. Some boards don't have metal on one side, only on the other side. And if that was the case, then that's
There's our correct side.
this one doesn't matter. So you can see I pushed it all the way, spread the legs to hold it down, and go ahead and put some more in there. Then we're gonna flip it upside down to see the underside. Yep. That's why you have the flush cutters as well, because after you solder, you're gonna cut them off with the flush cutters, and it's gonna leave a perfect little solder joint. My own seminar. Well, I do little public speakings here and there, but interesting. I don't know. We'll see. Maybe someday I'll work at one of these companies that has like their own biomed school or something. Who knows? Okay, so always pull it all the way down as much as possible, and then spread the legs like that.
And then soldering?
Yep. So on the back, all we're gonna do is here. Actually, I should probably show that up close on the camera. All right. Let's see. Camera. Camera, stop. Okay. Stop, camera. Okay, there we go. All right. I'm going to pull you guys in nice and close so that you guys can see what we're going to do for through hole. This is called through hole soldering because the component is on one side and on the other side are the legs. So what we're doing is you take a resistor, you bend the legs over, you poke them through the holes so that they stick up on the other side. You see that? What I'm going to do is I'm going to open this vise. Let's get rid of these. Okay. Would you guys like to use the vise for soldering? Okay, let's see if I can show you guys right close what I'm going to do. Okay, so here's the legs of my resistor. I hope that's in focus, guys. And let me get my soldering iron. And let me get a little bit of this here. Oh. Okay. All right, guys, you ready to see the through hole? All right. Here, let me bring this guy over since it's got my cleaner. Okay. So my component is on the bottom side. The legs are sticking up. So for this here, you want to make sure that you got a clean iron. You're going to stick it down on the via. That's what it's called. It's the hole that is going through the board. So you're going to stick the iron on the via up against the leg, and you're going to heat it up. And you're going to feed some solder down into it. You see that? And it happens really quick. So you want to heat up the board and the leg. And here, let me put a little bit more on this guy. So I'm not heating up the solder, I'm heating up the board and the leg, and then I'm melting solder into it. And then we get our flush cutters. Oh, and I promise you, that guy's warm. As you can see on one side, the solder, I didn't feed too much because it's like water when it's hot. It'll keep going through the bottom side and it could short stuff out. So you feed just enough in, and I know it's not really showing up very well, but you want it to form like a little cone on the leg. Okay. You guys can go ahead and take a look at that. So the point is you heat up the metal on the board and the leg, and then feed the solder down into it. Don't heat up the solder because it won't stick. It just won't work. All right. Okay. So you guys can see the point is to not get too much solder on the underside of the board because that will create shorts. And you clip it off so it just creates little bumps. And that is through hole soldering. Okay, whose board did I take over here? Here. You can have your board back. Yeah, you're welcome. Okay, let's try it again. There. Come on, camera. I don't think the AI on this camera works as well as they say it does. Okay. It depends, I guess, because the type of lights that I'm under and the fact that I've got really white skin, it just isn't showing up really well on the AI. Huh. Okay. Anyway, you guys want to use a vise to hold the board? Okay. No vise. Just stick the board in this ledge. Oh, look at you. Those look good. Oh, it's excellent, man. Excellent. So the last thing that we're going to cover is solder wicking, which is possibly the hardest thing out of all of them. So go ahead and put all the components, all the resistors I gave you guys. You want some more resistors? We got lots of resistance over here. Let's see, what do we got? Let's go with, how about a 47K ohm? Put some more in. Because we are going to solder wick some of these free from the board. So you think it's hard putting them in. Ooh, just wait taking them out. There you go. Put them right next to each other. There you go. Touch the iron to it. Hold it in one spot. There you go. Yes. Excellent. Perfect. Okay. Man, I just got out of work. Well, I'm still at work, man. Still at work. You guys getting those winter storms out there? Tell you what, we're supposed to get one tonight, tomorrow. I don't know what a winter storm is for Houston. You guys could laugh at it, but here, like, people drive like nuts. So. Let's take a look. So when they're like this, see that bulb? It should never, solder should never form a bulb. You touched, is it iron hot? Yeah. Okay. See, all you gotta do is touch the iron to it. See how it goes down to a cone? Yeah. So I touch the iron to the board, down to the hole, and you see it. It'll go through and make a perfect little cone. Like that. Go ahead and put a couple more in. Those are looking pretty good, man. Tell you what, it's a good thing we got these new workbenches because it would have been impossible doing this on the old light.
Yeah.
Impossible. When I came here and y'all were working in these dark conditions, I was like, what are you guys doing? Here I was thinking I was just a little too old. So the only thing I've noticed is that on at least one board, the solder didn't melt into the joint. It was kind of creating a bubble. So if you guys ever have that where it creates too much solder on the surface and it creates like a bulb like this, it should never be like that. Just touch it with your iron to the socket and to the bulb, and it will melt down into the via, and it'll form a nice little perfect cone. So just a little bit of touch up. Also, when you have too much solder like that, it could be a cold solder joint. So always touch those up. Let me take a look at this. Those look good, man. Those look good. Nice one. This one's cold. See the little hole in the middle? So what we're going to do, let's see. Oops, dirty. Put some solder on it. Make sure it's nice and shiny. Okay. Oops, I moved it. But here, let's do it again. There we go. So if the tip is dirty, clean it, put some solder, clean it, and then do it. That looks good. Excellent. So, yep. All right. Yep. So, solder wicking is next. And I promise you, when you see my technique for solder wicking, it's going to change the way you think about it. Because a lot of people don't like solder wicking. They say it either destroys the board or they have to inject too much heat into the board. Not true. Technique is everything. All right. What's my main job now? Well, what is my main job now? Good. That one there almost forms a ball, but I checked the other side and it looks good. Those are good.
Okay.
Absolutely.
Are these okay?
Let's take a look. Those are good, man. Really good. Yeah, well, so the whole key is making sure that you use extra. You can either use Flux if you want to. If the wires are dirty, like sometimes wires are dirty, man.
Yeah.
And if they had any heat or something like that, because some current ran down it, the copper's gonna be dirty. I have to use Flux.
Okay.
But just add solder to it, and then let the solder drip off. That's why you got the silicone mats, is because solder won't stick to them. Like I got all sorts of solder over here. It's fine. Just add extra solder to it. It'll clean the joint and bond. Just make sure you hold those wires perfectly parallel. And right now I've had maybe too much caffeine. The whole wire is really, really fine. So no I'm not a supervisor per se. Actually, the team lead is sitting right over here behind me. I guess it was yawning last video. I'm more like a consultant for the service department, and I basically go out and find opportunities. So places to make money, business connections, and stuff like that. That's a lot of what I do. And I break things. I break things. All right. All right, you get a good stream going. Okay, now we are going to solder wick. And solder wick is, it can either make or break you. I'll try it with the vacuum. And I'll show you guys with the hand vacuum. You guys got really good hand vacuums, the one that came in the kits. And the reason I know they're very good is because you plug the end, and you get this. See how it didn't go all the way up? Yeah. That's a good suction pump. So that's how you test them, is you put your finger on the end, you hit the release. All right, so we are going to do some solder wicking. Okay, let's come over here, and boop, and stop, or stop. Okay, still following me? Why don't you ever work? Okay, ready? Stop. 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 Okay, still moving? I hate you. Okay, does that work? You guys think I'm goofing around. There's a light on the camera, and it's telling me if it read my command. Okay. You guys think I'm just doing some goofy hand motions. There it goes. There it goes. Right? Got you. Got you. Okay. So I'm going to bring you guys in nice and close, because this is probably one of the most important things that we are going to learn is solder wicking, because you can really damage a board if you do it wrong. And believe it or not, a lot of people are doing it wrong. Okay. Not very stable, huh? Okay. So let's get, who's got a board? Anybody got a board? Give me a board that's got a lot of joints, because I'm only going to take off one, maybe two of the socket. Yeah. Who's got a whole lot? Let's go ahead and set that up. And can I get that vise that's over on that table, please? Oh, is that a junk board? Yeah. Oh, sweet. Okay. Okay. Cool. Okay. So we have a victim, guys. All right. So on this board, some of the components that fail really often are your capacitors, and also your solid state components. So you have a bridge rectifier that sometimes fails, and you have a switch, high frequency switch. So we're going to pull this guy right here. Okay. So we got this MOSFET right here. I'm going to take off. All right. And let's do this. Okay. So as I said before, I'm going to add some solder to it, because this is lead-free solder that's on here. Clean it, add. Good. Also, one of the things I forgot to tell you guys, you see the tip that I'm using over here? It's the shaved off like oval. Mm-hmm. See how the solder just wants to stick on it? The shaved off oval is one of my favorite. You guys also have a wedge. So the wedge tip is really good, and the shaved off oval is good. This one here, the conical tip, no good. It's okay if you're working on joints like these little guys, but for the most part, I use this shaved off one right here. Okay, and you can see why. Like the solder sticks to it so much nicer. So I'm going to feed some into it. Boop. So when I feed a leaded solder into a lead-free joint, it creates a new alloy, okay? Because they both turn into liquids, so it gets some of the properties of the leaded solder, and it's got some of the properties of the other one. And one of the properties is the lower melting temperature. So this is lead-free solder. Like I said, it normally wants a really high temperature, and it's normally a pain in the butt, especially if you've got multiple pins, to get all the solder liquid. So what I do is I add a little bit of leaded solder to it. You see, each one I touch for like a second at the most. I'm not holding it down there. I'm not killing it. Okay, so we are going to use, there's quite a bit of solder on there, so I'm going to use the thicker one. I'm going to clip it off. Okay, and this here is an acid flux. So this one, I have to remember to clean the board. But this is the technique that a lot of people, I think, get wrong, is they'll put this straight on here and they'll try and get it that way. What I do is I put the wick in the flux and I touch it with the iron and it liquefies the flux and gets it inside the fibers. You see how it's shiny, it's wet looking? The flux is now inside the wire and now it's going to seep. It's going to suck it all up. So what I'm doing is I'm placing the solder wick right next to the joint and I'm heating up the joint and the wick, okay? And this is going to get very hot, by the way. So if you guys like your fingertips, hold them back. Don't do like me. You see I'm holding it with my fingers. Copper conducts heat very well, and it sucks. So I burn myself all the time because of that. Okay, so let's see. Let me get this guy right here. Okay, see how I'm putting the iron down at the board? I'm heating up the board and the pin, which is causing the solder to flow into the iron or into the wick. And then, what I'm doing is I'm pulling the wick a little bit, keeping the iron in one spot. This is going to take practice, guys. You will not get this the first time. So we heat up the joint first, and then we pull it. Okay, just a little. If you move this around on the board too much, you could pull the pads off and destroy the board. So don't pull this guy around very much. Let's melt it. All right. So you can see the clean sockets. See? So if it looks like it's burnt, it's not burnt, guys. That's the flux. Here, I'll show you. Here's an example. Let's use some of this. Okay. You see right there. That's just melted flux on the board. So if you think I burned the heck out of the board, not so. Okay. So that's one way of doing it with this. All right. So you add some solder to it. You get this guy down there, stick your soldering on it, and on this kind of half and half. And then I just pull it a little bit, and you can see it'll kind of seep into this. All right. It's going to take some time. It's the hardest technique to use. And then, the thing we're going to do, you can see I'm putting new solder on it. The reason I'm putting new solder on it is because I'm going to show you guys the suction gun, okay? So this isn't something that you guys will have to do today. I'm just showing you the proper way. So if you get a board, you'll know what to do. These components, the capacitors, are all things that we change out. We got fuses. Again, that's something that you'll have to desolder and take them out. Remember, if a fuse pops, there's a reason for it. Let's see. Let's get this guy nice and hot, and I'll show you how the suction gun works. And for the suction gun, I'm going to put some flux down on it. Okay. See. Okay. Almost ready. Oh, shoot. Okay. Well, we'll work on these pins over here. So there's different nozzles for this gun, and you can see this one's got a tiny little opening. That's more so for these pins right here, and it's 720 degrees, so I'm not going to change the tip. But normally I'd put on the big tip, and then we can change those guys out. But I'll show you guys what we do on these ones. Right. So with this guy, come on. All right. So what we're going to do is we're going to stick it over the leg, like right down the wire. Right. And you see what I did? Yeah. Nice clean hole.
Yeah, that's good.
So I'll show you how fast we can work with this stuff. Let's see. See how I'm moving it around too, because I'm making sure that, remember, the solder follows the heat. So by me moving it around, I'm making sure that the solder is completely liquid. Look at all those.
Yeah.
Way, way easier. And that port will just fall right out. So when we get a broken port, we can move stuff like that. Like if you have video ports or AC ports, you know, for like the laptop power or something like that, you can take those off really easily with this gun. So let's plug this guy in, and I'll show you guys how long it takes with the solder wick. Okay, let's do this. Let's get some flux. Okay, and we'll do the soldering iron. So you can see what's happening. It's sucking the solder up into it. And those joints are pretty clean. So there I got 3 joints in the time I did like 5 or 6.
Yeah.
So there's the advantage. So you guys can see what's going on. These are the pins that I did with the suction gun. These ones over here. Remember that burnt is not actually a burned PCB. That is just burned flux, which that happens. And we just got to remember when you're done, clean the alcohol off it, and you know, clean all the flux off it, and clean the board really good. And that's it. Too easy. All right, guys. I am probably gonna have to end this live stream right about here. Thank you, man. I was just gonna walk around with a mess on my hands. So you guys out there, those are all techniques. I can't convey that through a camera. So this is one of those things where you just have to practice, and you have to get down there and you have to do it. Your iron and your tip are gonna dictate like things like how your heat is gonna transfer into your solder wick. So your tip is gonna matter. Your temperature is gonna matter. Your diameter of the solder wick is gonna matter. It's gonna take practice, and that's why I'm not going to make anybody here go through the whole solder wicking thing. Maybe some other time. It's just not going to be worth it because it's going to take so much extra effort. Khan is a biomed in Belgium. Hey, man, thanks for tuning in. I appreciate that. Well, I'm actually fortunate that I had this old board. Now, maybe some other time I can show you guys like proper component replacement, because things like this port are some of the most common things that we're going to change out. Having that suction gun definitely helps. The other way is using this guy. So you have to get this guy down really close to it, heat it up with the soldering iron, hit it with this. It works. It just takes longer. All right. So guys, before you take care of your soldering iron, remember to clean the tip and then apply some solder to it. Okay. It's called tinning the tip. And then go ahead and leave it docked with the solder on the tip. Okay. Yeah. Always leave a little bit of solder on the tip when you go to shut it off. Also important. Ash is asking, what topic is next week? Okay. So, guys, you should know that I've been doing my research this week, and I have been trying to direct these trainings towards the CABT or eventually the CBET. um, I was exploring around the Amy website this morning, which is not a good website at all, and trying to figure out exactly what type of stuff is going to be on the test. And it's like a giant mystery. It really is. And I would like to know, like, these areas, physiology and anatomy, are going to be covered. I want to know that, digital circuit theory, analog circuit theory, whatever. And I know that they have a pamphlet which covers some of the stuff that's going to be on the test. I started going through the pamphlet, and it's vague at best. So I looked on the website for study guides or anything like that. Nothing. And if there is on there, and I spent like over an hour searching for it, it's not a good site. So I would love to tailor these towards the CBET, and the only way to get that is to invest into flashcards and invest into the study guides that some publishing houses is printing out. And I have those. I put money into that, and I have those. So eventually, we're going to turn this into more of a study group. I'm going to go over. I have the flashcards and all that. So I'm going to cover like certain areas, like problem solving, um, maybe physiology and anatomy. We're going to do that maybe next week, I think. Um, Physiology and anatomy is one of those things where you don't have to be in this room to learn, but we're going to cover it at least to the level that I think they're looking for on those tests. Okay. So that would be all the different body systems and how different organs function and what they do. Nothing that you can't learn on YouTube already, but we're going to do it more so from a biomed perspective. Okay. So I think anatomy and physiology is going to be coming up pretty soon. Okay. Now, electronics basics. See, that's just it. Is I don't. I want to get these guys ready for the CABT, and I don't know what level of electronics they want to cover. I don't know. It's vague, and that's part of the problem I have with it, Amy. So I wish that they would, have their own study guide and study these areas. If you want to take the test, you know, the price on those tests is absolutely ridiculous on the Amy site. Okay, first off, I'll say that absolutely ridiculous. So if it's going to be that expensive, I would like to know what we're studying, right? So just studying everything in general for biomed is probably not good. But I do have study guides. I do have the flashcards, and we're going to use a little bit of all that. And what I really want to cover is the basics for the career field, and then I want to get into like the flashcards, like why did they say this. We'll maybe deep delve into a few of the flashcards and cover some of that as we go. I eventually I want to turn this into like a CBET study course. Not that I'm endorsing it or anything, but this is all just general information we should know anyway, right? So, guys, that's the general trend. I'll have to think about it, and I'll let you guys know ahead of time what we're gonna study next week. I'm thinking anatomy, physiology, because we can cover the anatomical structures and what the different systems do in the body, and we can cover that pretty easily, I think. Um, there's a bunch of stuff. I'll have to do a little more research before I give that one out. All right. Let's see. Oh, you guys. Hopefully. Well, thanks, man. So I shut off comments on some of my videos, and I'm thinking about shutting off more comments because some people just got like really nasty, and some people were just being argumentative for no real good reason. I mean, people wanted to argue about like the plugs and how I said the holes in the plugs are for when they mold them. I even had video to prove that point. Should I have to prove it? No, go do your own research. They're used for lining up the pins when they mold the plugs. If people wanted to argue with me about that, people wanted to argue with me because I said a couple things wrong um, while I was balancing out this audience, you guys, and that my camera issues and whatnot. Some things are going to be wrong. That's all there is to it, man. shoot, half the stuff I say is wrong. I promise you that. But when it comes to fixing things, I can fix things. That's a promise. Well, I was after that first live stream, I was starting to think really heavily about should I shut down live streams and just knock it off. And I was like, you know something? I eventually want to turn these live streams into like a Q&A because people are watching these live streams from all around the world. And I want them to turn into a Q&A, not necessarily so I can answer the questions, but so other people that are watching can answer the questions. And I've got the professional version of Zoom. So maybe I want to migrate away from doing this on here and maybe do it with Zoom. So we can record the discussion, a live discussion. You know, I can see other people's cameras and, you know, we can actually have a real discussion. One of the things I want to talk about is maybe things like the CBET. Like, is it really necessary? Think about it, guys. There is a huge supply and demand disorder. All right. And when every single hospital that I even know of is hiring biomeds right now, they can't find enough qualified people. You really think that they're going to limit themselves to CBET? Really? Not going to happen, guys. I'm going to do a whole discussion on that about what's going on in the job market. Maybe I'll do that with a Zoom meeting. And we'll, you know, with my Zoom meetings, I can have like 200 people on there at the same time, which is pretty cool. So each of you guys can have a voice at the same time. So when we talk about topics like the amount of equipment per technician, it's getting a little out of hand. It's everybody's kind of developing a lick and stick PM program everywhere, you know, and I want to talk about that with you guys, you know, live. I want to hear you guys' voice on it too, because everybody is getting a little miffed about it. You guys, we are going to do another giveaway very soon. I was going to give away a multimeter, but if I'm going to give something away, I want it to be nice, and maybe I'll get a nice multimeter. I got some tool videos I'm going to release very soon, and I've got a backlog of videos I haven't even released. You know, going back 6 months, and some people that I interviewed and whatnot, I haven't released them yet. It's a timing thing, and maybe I'll find the time to make it happen, because it's coming into April, May, June. I'm going to be going to a lot of events coming up, so I got all that footage I'm going to have. It's going to be crazy. How you guys doing? You guys almost ready to go home? You guys expect it to be icy tomorrow?
Yes.
Really?
Yeah.
You really? I drive like 45 minutes to get to work. Oh yeah, from Katy. Yeah, I'm south of the 10. I'm down by West Park Tollway. I'm down there, man. But it's a beautiful area. But geez, it's a drive. I see a lot of cows on the ride up here, though. There's a lot of cows. I grew up near a dairy farm. My family owns a large dairy farm, so a lot of cows in my life. I can't get away from the cows. My family had a pig farm too. Yeah. Like my dad, mom, that family, we had a pig farm. We had a couple hundred pigs. Toronto, you're having another possible weather storm. Ooh. You guys, I just expect that. Come on, it's February in Toronto. I mean, yes, you got truckers and storm. That's the two things to look forward to, is your mass protest and your winter storms. So this is Texas, man. We're supposed to be eating barbecue and like drinking beers in February without snow. I grew up in Michigan. I'm used to snow, lots of snow. Even here, like people are making comments like, "You cold?" Because I wear this beanie around a lot. From Michigan, we wear a beanie around 3/4 of the year. It's not a style thing. There ain't nothing styling about me, guys. I'm okay with that. All right, let's shut this guy off. Everybody got their irons unplugged? Okay. Let me put this stuff back up. Okay, you guys. It's 2 hours now. Thank you all very much for watching. And you guys that are going to watch this in the future, I hope you learned something. I would like to do another video, maybe under a microscope, and showing you guys exactly what happens at a metallurgical level when you melt the solder perfectly between wires and stuff. You can actually see it. And when you know what to look for, that's how you develop your technique. So I would like to do that coming up very soon. And guys, I am going to have to end this business. Can't get away from it, guys. Thank you guys all for watching.